In this video, we're going to take a look at practical optimization problems. So we have two examples to look at in this video. The first example, the cuboid shown has a capacity of 1800 cm cubed. Show that the surface area is given by A equals 12x squared plus 3000 over x. So we'll take a look at that first part first. And we're told, maybe I'll draw the cuboid very quickly. So we have something that looks like this was, and here, and here. No, we won't do that. So this is a rough drawing, obviously. And finally here. And the last one here. So we've got y is the height. We have 2x along this side, and we have 3x. So that's the rough drawing of the cuboid. Now we're told the capacity. Capacity is equal to volume. So we just say V is 1800 cm squared. Cm cubed, it is a capacity, a volume, centimeters cubed. We want to show the surface area. Surface area. We have to show that it's given by A equals 12x squared plus 3000 over x. So we're going to try and show that that is the surface area. Now we're given the volume, so let's look at the volume first. V equals 3x, the length by the depth 2x, by the height y. And simplify that, 6x squared times y equals 1800. Now we're looking to express the surface area in terms of x, so I'm going to eliminate y using the volume. So y equals 1800 over 6x squared, or we can say y equals 300 divided by x squared. Okay, so now we can look at the surface area A. So the area of the surface, we're going to have 2 times 3x times 2x plus 2 times 2x times y plus, what else have we got? We've got 2 times 3x times y, and that's each of the walls of our cuboid. So 2 times 3x times y. So if you look at what we did there, just go to a different color. So we did the front area by 2, front and back. We did the top by 2, top and bottom, and we did the ends by 2. So we have each of those picked up. So that is the surface area. And I'll go simplify it now. So that ends up at 12x squared plus 4xy plus 6xy. I'll just get a little bit more space. So our area is now 12x squared plus 10xy. 10xy, and we have y is 300 divided by x squared. Just subbing the y that we found equals 300 over x squared. So now we can simplify that to area equals 12x squared plus 3000. Now x divided by x squared will give us plus 3000 over x, which is in fact what we were asked to find in the first place. I'll go back to the question now because we'll take a quick look at that. Area given by 12x squared plus 3000 over x. Now the second part is to find the value of x, which gives the minimum surface area. So let's just look at that. So we're looking for the value of x for minimum. So if it's a minimum, we get the first derivative of a with respect to x. dA dx equals 24x. Now this is 3000x to the power minus 1 becomes minus 3000x to the power of minus 2. And we can set that to 0 and solve for x. So the first derivative set to 0 and solve for x. That should give us the value of x such that it is a minimum. So let's just take a quick look at this. 24x equals 3000 over x squared. So we can rearrange this. If I divide 24, if I divide both sides by x, I'm going to end up with 24 equals 3000 over x cubed. And I cross multiply, so I'm now going to say x cubed must equal 3000 over 24. And 3000 over 24 is in fact 125. So x cubed is 125, so therefore x is the cubed root of 125 is 5 cm. So 5 cm is the value of x, which we assume is going to provide is a minimum, but the next part of the question we're going to have to show that it is a minimum. So the next part of the question is find this minimum surface area and confirm that it is a minimum. Okay, so we said surface area A is given by 12x squared. Now x we found to be 5, 12x squared plus 3000 over 5 over x. And when we calculate that, that gives us a value of 900 cm squared. So we have 900 cm squared. So that is the surface area. To confirm it's a minimum, we'll get the second derivative, d2a dx squared equals, so we're getting the second derivative, so we have 24. Negative 2 times negative 3000 is positive 6000. And that is x to the power of minus 3. And when we sub in x equals 5, we will indeed get a positive value. Let's have a quick look at that. 24 plus 6000 times 5 raised to the power of minus 3, close brackets, and we get 72. Now 72 is greater than 0. It's a positive quantity, so we have minimum. Okay, so that's the first example completed. Now we'll go back, take a look at the second example, And we're just doing 2 in this video. So the second example shows a solid cylinder that has a total surface area of 294 pi cm squared. And the first part, we want to find h in terms of r. So I just go across to the math pad. I'll do a quick sketch of the cylinder that we were given, and I'll just do this by hand. So the cylinder, not a great sketch, but so the radius of the cylinder is r, and the height is h. And we're asked to, first of all, we have to express, well, let's just write down the information we were given. So the cylinder has a surface area and the surface area we're told is 294 pi cm squared. So we want to find h in terms of r. So h in terms of r. So h in terms of r is the surface area pi r squared. Now that's the area of the top. Now we need to take into account the area of the bottom as well. So we have 2 pi r squared plus the area of the sides. Now the area of the sides will be the circumference of the circle, 2 pi r times h. And we're told that equals to 294 pi. So we can easily eliminate h, and we will have the h in terms of r. So we'll rearrange this. We have 2 pi r times h equals 294 pi minus 2 pi r squared. And I'll divide out by the 2 pi r, giving me h in terms of r. So 294 pi minus 2 pi r squared, all divided by 2 pi r. And that will simplify down, and that gives us a figure of 147 over r minus r. So there's h in terms of r. Now I'll just go back to the question, remind us what the second part of this question was. So in the next part we have to show that the volume of the cylinder V is given by 147 pi r minus pi r cubed. Okay, so we'll just go back to the writing pad, and we're looking to show, I write down what we're aiming to get, so we're looking to show the volume is 147 pi r minus pi r cubed. So the volume of our cylinder, we know, is V is given by 2 pi r, back to pi r squared, it's not 2 pi. So the volume, the formula for volume is pi r squared by h, by height, and we'll sub in the h that we worked out in terms of r. So it's pi r squared, and I'm doing a sub in the 147 over r minus r. And I can see already that we will get what we're hoping to get, which is pi, it's 147 pi times r, because r squared divided down by r is r, minus pi r cubed. Okay, so that's part 2. We've shown volume in terms of r. So go back to the question now again, just to get the next part of this question. So the final part is find the value of R, which gives the maximum volume, and confirm that it is a maximum. So I'll just go back, and we're looking to find the value of R, which gives a maximum, so we need to find the first derivative, dv dr. So dv dr equals 147 pi minus 3 minus 3 pi r squared. And we must set that to 0 if it's to give us a maximum, and we'll solve for r. So we have 3 pi r squared equals 147 pi. I can say r squared equals 147 pi divided by 3 pi, which gives me 49. If r squared is 49, r could be plus or minus 7, but we know the radius can't be negative, so we're just going to go straight to saying r is positive 7. Now we need to just show that this is in fact giving us the maximum volume. So to do that, I'll get the second derivative, dv d2v dr squared, and that gives me negative 6 pi r. And it is a negative quantity, but let's sub in r equals 7 just to conclude. R equals 7, second derivative d2v dr squared is in fact negative 42 pi. This is less than 0, therefore we have maximum. Okay, so that's it for this video. Thanks for watching.